friends. We're back here speaking to luminaries and people who are disrupting the world of science and also spirituality. I have a very special guest today, and he has a book. It's called Notes on Complexity, a scientific theory of connection, consciousness, and being. I'm reading the book. It's very fascinating. I have a lot of questions for Neil, and we'll start right off the bat. But before I will read to you what the flap cover says, but before I do that, welcome Neil to this conversation and congratulations on an extraordinary book.
Thank you, Deepak. As you already know, this is actually the first time I'm seeing my book. You got a copy before I did. And
it looks beautiful.
I'm really, I'm very pleased, to say the very least.
Has some great praise from people like Stuart Kaufman, MacArthur Fellow of the Royal Society of Canada, from J. Song Khapa, Professor Emeritus Columbia University, Mark Epstein, and many, many others. And I, of course, am a very enthusiastic endorser of this book as well. So, before we do that, let our audience know a little bit about yourself, Neil, just a little bit about your background, both personal and your interest in, in Zen, and also how you are basically an explorer of consciousness, but also a scientist. So let's get a little background.
Okay. Since I was a kid, I've sort of been two-track. On the religion side, I was raised in a very warm, supportive Jewish home in which we were more observant than our average American neighbor. My parents were European and came here after the Holocaust, basically. And I took that practice deeper than they did. It was something that I was really interested in, and it sparked me. And on the other hand, I was a science nerd as a kid. The world fascinated me. I think those two things came from the same impulse from when I was very little, when I look back. And I think this is true of most children, but often it's lost, that there's a simpatico, a sympathy with the world, and which breeds interest and curiosity. And I think scientists, for the most part, start there. And I think for a lot of people interested in religion and spirituality, it often starts there. For me, it certainly did. Our culture says those things aren't compatible, and I didn't really care, maybe because I'm a Gemini. So when I went to college, I majored in Judaic studies. On the one hand, I was thinking of becoming a rabbi, and computer science and systems theory on the other, because that was I think I signed up for 12 majors, and it was too late to change. I landed on that for some reason, and then it was too late to change again. And then I was pre-med, and for a variety of reasons decided that that's what I wanted to do professionally. Went to medical school. Science was here, religion was here. By this time, I had become interested in Jewish mysticism, which at that time was not available to a middle-class, non-Orthodox Jewish kid who grew up in the suburbs. And so I landed in Zen practice because I perceived that Zen was sort of non-deist, non-theistic, at least superficially. And so I could bring that in alignment with my Jewish practice with some comfort. Those distinctions don't mean anything to me now, but in my 20s, they were still important. On the medical side, I became a pathologist. This is my microscope. I look at people's biopsies all day long, diagnosing cancer, not cancer, things like that, specializing in the liver particularly. And through what I saw in human tissues in the microscope, about 20 years ago, 25 years ago, I started to realize that I could make a case for the liver having stem cells, which back then was controversial. now is to a small extent, but now it's a commonplace that all organs have stem cells of some kind. But that was novel back then. That took me into adult stem cell plasticity, which made lots of news in 2000. Our paper and the work of groups like ours led to George Bush's address to the nation, limiting embryonic stem cell research, because our research was showing that adult cells could do everything embryonic stem cells could do. So that was an interesting political moment in my career. But then pursuing the stem cell stuff, I wound up having a collaboration, an interdisciplinary conversation with an artist named Jane Prophet. And in talking about how I viewed how stem cells behave, she drew my attention to complexity theory, complex systems, which is basically the theory of how interacting individual elements, whether it's people or cells or ants in a colony, interacting with each other at the local level, give rise to larger scale structures, like an ant colony, a finger, etc. And that got me thinking about complexity theory. And eventually, following where that road led, at one point, I had an evening where I was alone in the Zendo, meditating and obsessing about my stem cells as though we were a Zen koan, like what's the sound of one hand clapping? Experiencing my body conceptually as the stem cells that I was studying. And I looked up at one point and saw the incense stick on the altar turning into smoke. And it just suddenly hit me. Incense, smoke, body, cells. Which is it? It's both equally. The body is a community of cells and nothing more than that. But equally, the body is this object bounded by my skin, talking to your body through the screen, which is separate. And suddenly I realized that these two strands, I never had looked to find an overlap or a communication between my scientific practice and my spiritual practice. But suddenly at that moment of the Zendo, there it was. And since then, they've been one thing. And that has led me eventually, in part through meeting you, Minas Kafatos, who we both collaborate with, quantum physicist and cosmologist, and Kashmiri Shavist, and now a bit Buddhist too, that to take me into consciousness studies and how this applies to integrative medicine and such things. And so that's short enough.
Yeah, that's very good. My very special guest is Dr. Neil Theise. He's a professor of pathology at NYU Grossman School of Medicine. Through his scientific research, he has become a pioneer of adult stem cell plasticity and the anatomy of the human interstitium. He's also a longtime student of Zen Buddhism. Dr. Theise's studies in complexity theory have led to interdisciplinary collaborations in fields such as integrative medicine, consciousness studies, and the science-religion dialogue. Let me read a little bit from the flap.
Sure.
Nothing in the universe is more complex than life. Throughout the skies, in oceans, and across lands, life is endlessly on the move. In its myriad forms, from cells to human beings, social structures, and ecosystems, life is open-ended, evolving, unpredictable, yet adaptive and self-sustaining. Complexity theory addresses the mysteries that animate science, philosophy, and metaphysics. How this teeming array of existence, from the infinitesimal to the infinite, is in fact a seamless living whole, and what our place as conscious beings is within it. So physician, scientist, and philosopher Neil Theise makes accessible this theory of being, one of the pillars of modern science and its holistic view of human existence. He notes the surprising underlying connections within a universe that is itself one vast complex system between ant colonies and the growth of forests, cancer and economic bubbles, murmurations of starlings and crowds walking down the street. The implications of complexity theory are profound, providing insight into everything from the permeable boundaries of our bodies to the nature of consciousness. Notes on Complexity is an invitation. This book is an invitation. To trade our limited individualistic view for the expansive perspective of a universe that is dynamic, cohesive, and alive, a whole greater than the sum of its parts. Theise takes us to the exhilarating frontiers of human knowledge, and in the process restores wonder and meaning to experience of the everyday. So I've been reading, I have a lot of questions, but I want to first ask you, Neil. We'll go over these sections, okay?
Sure.
So just off the bat, and keep, I've summarized the book anyway, keep the answers succinct. So define complexity.
So as I said, it's concerned with interacting things that when they interact with each other, create larger scale structures, if they fulfill certain criteria. So the example I use in the book very extensively, and people seem to like, because everyone grew up with ants, is ant colonies. And so there's with ant colonies, you have very detailed structures. You have food lines, you have the nursery for baby ants, you have a cemetery for dead ants, you have a dump for refuse, but there's no ant in the colony that's organizing all of these things. No one sets it up. There's no top-down organization. The queen ant doesn't have an administrative function. She just serves a reproductive function. All these elaborate structures happen from the bottom up. And that's what complexity theory is about. And it defines 4 very simple criteria that if interacting individuals fulfill them, then this emerging structure, it's called emergence, these magical things that arise without anyone planning them, happens. So the 4 things are: how many interacting elements are there? Do you have 10 ants, 100 ants, 10,000, 100 people, 1,000 people, 100,000 people? The difference is the more people you have, the more diversity of interactions, the more likely for creativity. So all of these things are similar across all scales. The same math applies, but a village is not a city, is not a megalopolis. So numbers matter. The second, which is one of the most important, is that there have to be feedback loops, negative feedback loops and positive feedback loops. So a negative feedback loop is how an air conditioner will turn on until you reach a certain temperature, and then it turns off. So negative feedback loops keep living systems within a homeostatic, meaning a healthy, self-sustaining boundary. A positive feedback loop would be like a room in which the hotter it gets, the higher the heat turns up. And sometimes that's useful in a system, like a body needing a fever if you have an infection. So you have a little positive feedback loop that predominates. But overall, you need an overall balance. It has to favor the negative feedback loops, the homeostatic feedback loops. If you have the positive feedback loops predominating, you do get self-organization, except then instead of adaptive and creative, it's energy expending and rapidly expansive and then collapses. So think cancer, economic bubbles, which today in the news is very prominent. All of this can be understood, the banking system, in terms of the rules of complexity. The final one of the 4 is the most interesting. There has to be a low level of randomness in the system. And what that means is if there's too much randomness, then you don't get organization, you just get complete disorder. But if you don't have any, if you have just a perfectly rigid system, then it becomes machine-like. It can't change in response to a changing environment. If the food line the food runs out, if you don't have a little bit of randomness of ants who aren't on the food line, who are the ones who might find the new food, then the ant line just keeps going back and forth, even though there's no food, there's no adaptation, and they all starve to death. And you have a mass extinction event. So you need a low level of randomness in every system in order for the system, whether it's people forming cultures, whether it's the cells in your body forming your tissues and organs, ants in a colony, you need that little bit of randomness in order to adapt. And that's what life is. This is why complexity theory is a theory of how life happens.
Okay, so very well summarized. That's part one of the book, A Science of Being, Order, Chaos, and Origin of Complexity, Rules of Complexity, and the Adjacent Possible. So one thing to comment here, a while back, first of all, by the way, where did your parents come from? Which country?
My father was born in Germany, went to England on the Kindertransport that rescued 10,000 Jewish kids just before the war. And my mother was from England. And that's where they met for the first time as children, actually.
I see. Okay. Okay. So based on what you've said, a while back, I had a debate with Richard Dawkins, and I happened to quote Freeman Dyson, whose book I have somewhere here in the room. And, you know, Freeman Dyson in his book, Infinite on All Sides, Infinite on All Sides, as you know, Freeman Dyson, probably then the only living physicist from Einstein's times, very prominent in Princeton and also British. I quoted him in the debate as saying that every quantum experiment forces the atom or the particle to make a choice. And, you know, that irritated our friend Richard Dawkins. And he said he couldn't have said that. And if he did, he's wrong.
But he did.
But if he did, he's wrong. And if you're misquoting him, he should sue you. He said this in public. So I wrote to Freeman Dyson and I said, you know, I quoted you, and are you going to sue me or whatever? And Freeman Dyson sent an email, which I preserved for posterity. He actually sent it to me and to Richard. Oh, by the way, I'm at peace with Richard and we're at peace with each other. No hostility. So what Freeman Dyson said, 3 riddles have occupied my awareness all my life. The number 1 riddle is the unpredictable movement of atoms, particles. Number 2, a universe fine-tuned for mind and life. And number 3, our own consciousness. And he said, I don't know the answers to these riddles, but I have a feeling they're connected. So the reason I'm quoting him to you now is you used the word random and he used the word unpredictable, but you also used the word creativity. So, you know, I know that in the later stages of the book, you talk about Kurt Gödel and the limits of formal logic. But the question here is, wouldn't the word unpredictable be more accurate instead of random? Because random implies inherent randomness and unpredictable implies it looks random to the observer, but it could be creative. I mean, I go to Grand Central Station, it looks all random to me, yet everybody is going to a particular destination. And if I plotted out a mathematical graph, I could even create a business out of it. So many people are likely to go to Philadelphia, so many to New York, whatever. So please answer this question. Do you prefer, because if we substitute that word unpredictable, then even Darwin's theory of evolution would be unpredictable, maybe creative mutations and natural selection. Please answer this.
Yeah, so first off, I don't say randomness, I say limited randomness. It's the degree of randomness that's important. Too much randomness, nothing creative and adaptive. But you're absolutely right. Whether you call it the small degree of unpredictability or the small degree of randomness, I think you can use both. They have slightly different uses, but from the point of view of complex systems, I think it's pretty much the same. And that is precisely where the randomness happens. So you look at that food line of ants, and there's always 3 to 4% of the ants that aren't following the line. Those are unpredictable. Those are limited randomness. It's not a million ants not following the line. It's 3 or 4. All the others are doing their business. But it's those 3 or 4, one of whom's going to wander into my mother's kitchen when I'm a kid. And I'm going to think it's a pathetic little ant that got lost. And before my mother sees it and kills it, I should take it out, which I would do on a little Kleenex. My mother knew, no, that random ant, part of the quench disorder, the limited randomness of the system, the limited unpredictability, is the one that would find the food in my mother's kitchen and lay down a new line for the entire colony to move into her kitchen. So it's precisely where the creativity comes from. Without it, there is no potential for creativity. And that's what allows for adaptation and for changes. Stuart Kaufman, and I use his phrase in the book, and I'm more than thrilled to have his blurb on the back of the book, talks about the adjacent possibles. Because of this limited randomness, in every single moment, there's a cloud of possibilities of what the next moment might be. It's not completely unconstrained. It's not every possibility at all. But, and we're not talking about parallel universes or anything. In this universe, there's a range of possibilities that what might happen next. That range is because of that limited randomness. He refers to those as the adjacent possible. So you have all these possibilities in your future. The next step immediately collapses everything down into the next moment as it is. And immediately, because of the limited randomness, the unpredictability, a new range of possibles opens up for the next moment. And that's how life unfolds. We can say that life will happen. We can say that it's likely to happen in this way or that way. But no living system is utterly predictable. It's always full of surprises. And the environment is inevitably going to change. From a Buddhist perspective or a physics perspective, the world changes in every moment. And so challenges will arise. And if you don't have those adjacent possibles, out of which one may be the thing that is the right response to that change in the environment, everything would die very quickly because there'd be no option for new ways of doing things.
Very well explained, Neil. Thank you. The second part of the book is complementarity and holarchy, and it has some very interesting chapters: the cellular level, the molecular level, the atomic level, the subatomic level, and all the way down space-time and the quantum form. So first, for our audience, you and I have had these conversations, and Menas also. It'd be good to define both complementarity and holarchy, and then give a very brief summary of this, because I want people to read the book.
Yeah. So complementarity, the classic thing, if people are science nerds that they've heard of it, they think about in quantum physics is light, a wave, or a particle. And the truth is, it is one or the other given whatever experiment you use, but in some way it must be both. But you can never see both aspects at the same time. The example I use, and there's a version of this picture in the book, you have that image of two faces looking at each other in profile, and the space between them looks like a vase. Is the picture two faces, or is it a vase? If you say it's a vase, you're missing half of the reality of that image. If you say it's the faces, then you're missing the vase. But you can only see the faces or the vase. Yeah, there you go. It's a famous image. I mean, everyone has seen it at some point or another, ground or foreground. So those images, like particle and wave duality, those images are both true absolutely equally. There is no preference for one or the other. And yet neither is a complete description of the whole. And so the holarchy we usually think of hierarchies, and a hierarchy would be, well, the faces are creating the space that looks like a vase, or the vase on a white background is creating the faces. A holarchy says the faces exist, the vase exists, and you need both in complementarity to explain the whole, to describe the whole.
Beautiful.
So the surprise, this is the rabbit hole I went down with complexity theory. There I am in the Zendo realizing my body is made of cells. Another example would be a murmuration of starlings. You hear a noise in the sky, and then you look up, and there's like this giant balloon or this spaceship. And then in a fraction of a second, you realize, no, it's a flock of birds. In the same way, you go down to the microscopic level of a bird, of an ant, or my finger pointing at the flock, and the finger, the bird, and the ant disappear completely. It's just a community of cells. And at the cellular level, we are not only our human cells, but we are the microbiome, the bacteria. Current estimates, 50% of your cells are bacteria, non-human, all over the surface of your skin. So every time you grab a doorknob, you leave a little bit of your human self behind, because without those bacteria, you could not be a living human body. They are part of us. If you kiss someone on the cheek or hug them, you're leaving some of you behind, and they're leaving some with you. So at the cellular level, what's the boundary of your body? It's no longer the skin. It's wherever your cells are going. We shed our cells into our rooms and fill them. So our boundaries are at least as wide as the people we encounter and the places we live and work. Are cells a thing, unlike a flock or a body? No, cells are just self-organizing molecules floating in water. So at the molecular level, the cell disappears as a thing, and now it's just molecules. Down a level in scale, where's your boundary? Well, simple example is we breathe out oxygen and the plants take it in and breathe out carbon dioxide. At the molecular level, our boundary is the entire biomass of the planet, exchanging molecules through every encounter. At a distance, close up. Are molecules a fundamental thing? No, they're just made of atoms. Where's your boundary at the level of the atom? Well, there isn't an atom in your body that you didn't drink, eat, or breathe from the planet. So in complementarity, we habitually view ourselves as these separate beings who have deep thoughts walking around on top of this rock we call planet Earth. But in complementarity to that, equally and absolutely the same being true, we are planet Earth, whose atoms have in 3.5 billion years self-organized into beings that think of themselves as separate. My favorite example, this is in the book, if you think about sending the Curiosity lander to Mars. When I first saw that, I thought, I already said I was that kind of kid. Wow, the engineers who were involved in sending a robot to Mars to send pictures back, how brilliant and how amazing it must be to be them. But equally true, it took 3.5 billion years for the Earth to self-organize its atoms to be able to reach out and touch its sister planet on the shoulder. And both of those things are equally true because it's a complementarity, like the faces in the vase. Are atoms a fundamental thing? No. Subatomic particles, what are those? Self-organizing something smaller, whether it's strings or loops or other particles. Physicists don't agree on that, but what they do agree on is that it's not an infinite regress to smaller things. Those smallest things come out of the energy-rich field, which is space-time, the fabric of the universe. And they just come in and out, forming matter-antimatter pairings, usually, in which case they just self-annihilate and go back. So it's this little bubbling kind of thing. That's why it's called the quantum foam. But sometimes a particle emerges that doesn't immediately self-annihilate. And then, in the manner of complex systems, these smallest entities meet each other and start to self-organize into subatomic particles, into atoms, into molecules, into people, into galactic structures, into the entire universe. So suddenly, the universe is one single complex system. And there's no reifiable, definable thing anywhere. It's all process, with the appearance at our level of scale as being things. This gives me, I think, what I hope the book gives to people, amongst many other things, is this notion that any view you have that I'm important because I'm this person, well, yeah, but you're also just a community of cells. My culture is important because it's important. Well, you're just about, there are always equally valid ways to view things if you change your perspective. And if you fail to give attention to that, you're missing half, at least, of what the world has to offer and can do. And if you pretend that one perspective is more important than the other, that's just as false. Even if you see both, but you prioritize one, that's also false. The two faces in the vase, absolutely equally important. Nirvana and samsara, absolutely equal and important, the same thing. So suddenly all this stuff lines up with Buddhist metaphysics, impermanence, interdependence, karmic law, etc. It all derives from complexity theory formulations. And that was one of my surprises.
Thank you, Neil. So 2 comments here. A few years ago, I interviewed about 100 physicists to see if there was one thing they agreed on. Because, they disagree on the interpretations of quantum mechanics. All 100 agreed on one thing, ultimately, and that was fundamental reality is boundaryless. And that's where you took us right now.
Right.
And therefore, I want to bring up a few things. In my own personal practice, I've never been able to visualize boundarylessness. Once you are without boundaries and formless, that means infinite, and infinite is incomprehensible. It is unimaginable. It is unperceivable. It's probably, as you're indicating, fundamental and without cause, therefore spaceless and timeless. And you can't actually perceive it, although transcendence allows us to experience it. And
that's the word, experience it.
Experience it without being able to, and the experience is ineffable. I think it's ineffable. Yeah. And that also brings us to the limits of human knowing. And I want you to address that a little bit. Our perceptual apparatus is only a narrow band of activity. There's a whole range of electromagnetic activity that's happening that we are not perceptually aware of anyway. Other animals are. Other species are, snakes, bats, insects, all experience a different world. And therefore, there is no single objective world, number one. And then there are other limits of human knowing. We can't imagine formlessness. We can't even imagine our own death. When we imagine our death, we survive as the observer of whatever we imagine as our death. And therefore, does science, which is based on faulty human perception, the earth looks flat to me. Nobody believes that anymore. The ground I'm standing on is stationary. It's spinning at dizzying speeds and hurtling through space, thousands of miles an hour. Neil appears on my screen as a 3-dimensional or 2-dimensional, in this case, object, but he's proportionately as void as intergalactic space. So what I'm suggesting here is that maybe science is not the answer to reality or any system of thought, including philosophy, including, mythology. The ultimate is only transcendence and experience.
And process.
Process.
Yeah. That's section 3 of the book.
Let's go for it. Let's go for section 3.
Okay. So, we live in a culture that reveres the materialist notion that everything in it arises from material substance. And that came about in part with the arrival of Newton and Newtonian mathematics, which could start to describe the universe as a machine. But as we've already discussed, complexity means inherently that the universe is not a machine and can't be a machine. From the bottom up, it is not machine-like. But there was this idea for a couple hundred years. And this was at the same time as all the systems of medieval churches in Europe. And I'm talking about this in Europe. This is not a global thing. Other cultures have other perspectives. But in our culture, so there was this feeling that the spiritual hierarchy and worldview was trembling, and this mechanical view was arising. The most formal and the most detailed version of this comes from the Vienna Circle, which was a group of philosophers in Vienna in the 1920s, who posited that, who stated that, and tried to prove that everything that was true about the universe could be proven either through empirical science or formal logic. And anything that couldn't be addressed by those two things is they dismissed as now I'm blocking on the word.
Superstition.
Yeah, so basically superstition. And metaphysics. They were just dismissed as, if they were having an argument, that's just metaphysics. The problem is that at the same time they were saying this, the quantum physicists had discovered non-locality and uncertainty and all these strange things that suddenly show that there's no separation of subject from object. And empirical science, as they defined it, is a subject explores an object, and there's a separation. And at the most fundamental levels, that's not true. It turns out that that's not only not true for quantum physics, it's also true in biology, and I've written on that a number of years ago. So that pillar of their certainty disappeared. What about formal logic? Well, there's this guy named Kurt Gödel, who is probably the greatest logician since Aristotle, maybe his better.
I'll interrupt you there, but I read somewhere that Einstein and Kurt Gödel would go for a walk every evening in Princeton. Yeah. That was their favorite time.
Right. And Einstein said the reason, which is sad because he wasn't doing very well scientifically then, he said the only reason he would go to the office in the morning was to have the privilege of walking there with Gödel going to his office. And they were both German-speaking refugees who were not in touch with the major processes of the moment. Einstein had not caught up with quantum physicists. He refused. And Gödel at that point was still causing trouble. And the trouble was that formal logic says that all mathematics can be built out of simple truths. And you can understand all of mathematics if you build up an elaborate enough structure of proof. What he showed is that, in fact, that was an impossible task. There were always going to be elements in a system that you could not prove, but you could know to be true. How could you know them to be true and yet not be able to prove them? Because you have an intuition that they're true. And so he opened the door to intuition in formal logic and therefore into science. And that's just metaphysics. And so this idea in our culture, which is really all about the Vienna Circle's concrete ideas, they were philosophers of science, amongst other things, and they defined our current scientific worldview. And within a decade or two of their definition, they were shown to be completely wrong, irreversibly. And yet we still propagate their ideas because that's one of the unexpected emergent properties of a complex system. Sometimes wrongness predominates for a time. So if Gödel allows intuition, then when you get to those things that are inexpressible, indescribable, and yet you can have an experience of it in a deep state of meditation, then you have access to a realm that is beyond empirical science, that is beyond formal logic and mathematics. And therefore, you've landed in the realm of the mystical and the metaphysical. And these are not invalid approaches. It requires perhaps even greater rigor to make sure you don't mistake a delusion, which may be as real as a profound spiritual experience. And so profound spiritual experiences usually have to be verified in community and between teachers and students over generations. But nonetheless, they are as valid as quantum physics and organic chemistry and engineering and complexity theory. And where we get in our culture around consciousness, and this is where, you know, thanks to you and Manas, this was the final road I had to go down. And you guys pushed and pulled me a little bit in the early years of our conversations. The materialist position is that our brain makes the mind. But we know that there's the hard problem of consciousness, that we can't, no matter how much we know about the brain, we can't explain how we experience the color of red of a rose, as a classical example. Some people get around that by saying they're panpsychists, and they say, well, actually, it's not the brain, it's cells are conscious. Some people will say there are kinds of molecules that are conscious or can conduct or create consciousness. Some people will say there may be a subatomic particle that hasn't come into the standard model yet that carries consciousness. But that just pushes the hard problem of consciousness down to a smaller scale. It doesn't solve it. The third possibility is what Gödel and quantum physics allow us to contemplate, that consciousness is what comes first. Max Planck, the father of quantum physics, said you can't get behind consciousness, because in the classical interpretation of the Copenhagen interpretation of quantum theory, it's the conscious observation that creates the nature of the world in the moment.
You're quoting Max Planck.
Yeah.
You said father. So this is a very good summary of the third section of the book, which is about consciousness. So let me, first of all, thank you for doing this interview, but I'm going to
Thank you.
Summarize a few things right now and see if you actually agree with me or you have another point of view. So right now, actually, if you look at, what is the ontological primitive of the universe, there are three competing theories. Matter-only monism. The problem with that is that nobody has actually experienced something called matter. We only experience a perceptual activity, which is, as we know, limited. And so that to me is untenable, matter-only monism. The second is dualism, which I think is also untenable. If mind and matter are two different things, how do I move my arm? It violates the laws of thermodynamics as well. What's the exchange mediated by? Okay, so that's out, which leaves us only consciousness, only monism, and everything else as a human construct. Now, this is very important to me right now, experientially, as I prepare for my last chapter, which is called death, and self-realization. But on the other hand, we are so stuck with the materialistic model because it's so successful. We're doing, we are having this conversation because of the success of matter-only technology.
Right.
And so we assume that because this model allows us to create technology, it is also truth. It is leading us to truth. But I think we have to go back to some very fun, you've laid the ground to say some things that great luminaries, great seers, great rishis have said. We come spinning out of nothingness, scattering stars like dust. Look at these worlds spinning out of nothingness. Rumi, of course. You are the universe in ecstatic motion. So what is the advantage in terms of life on our planet to recognize that each of us is, in fact, the universe in this temporary movement, in this temporary hollow movement? How does that bring solace? And how do we combine that deeper understanding and still find science very useful?
Right. That's the afterword of the book. I wind up in exactly the same place that you do. The only, I can't tell materialists definitively they're wrong. But what my book says is you can't tell me that consciousness as the source of all things is wrong either. There is no materialist argument to prove that. So my book keeps it modest, although we know what I think. It's a reasonable view in modern terms. If consciousness is the source of all things, and that consciousness is, as you described, you were the first person I heard say pure awareness, awareness of awareness, the non-dual realm, which is completely incomprehensible. There is no separation between subject and object. But out of that comes the universe. How does that happen? That happens because within that non-dual reality, as that awareness starts to sort of shimmy into being aware of itself, and then you get that, you develop a split between subject and object. The moment you have any slight separation, you have to have a separation in dimensionality, space and time. And suddenly, space-time comes into existence. And that energy richness and the whole universe. So the universe becoming aware of itself within itself as something that it can recognize, that creates the world. So what does that do for us now? I have a young friend, get choked up a little when I talk about this, who's very angry and very bitter about what we left the world. And part of me feels like I wish I had written this book 10 years ago, 15 years ago, because if it had become read and interesting and influenced people, if people had understood how to view the world from a complexity approach, like the whole banking thing. This is a mathematical complexity question. It isn't right and left. It's not political. It's just the way living things work. Would we be in the trouble we're in? And part of what I finished the book with is that we don't necessarily fix all these things because we have these understandings, certainly not if they're just purely intellectual. Mass extinction events happen. We're in the middle of one. How bad does it get? We don't know. I do know that 10,000 years from now, there will be a beautiful, strikingly dynamic world that has extraordinary ecosystems and species niches, just as miraculous as the one we have. Are we in it? Are polar bears in it? That's a separate question. But I've been close up and involved with 2 mass extinction events, at least. My parents were Holocaust survivors, and I know survivors who survived well with resilience and were happy, and that didn't mean they ignored or denied their suffering, but it didn't define them. And I know those who were broken by it. I lived as a young gay man through the worst of the New York City AIDS crisis. And I knew people who faced their deaths with extraordinary grace and brilliance, and those who went with incredible fear and anger. And I think that this understanding, these understandings, and more importantly, the practices, such as meditative practices, but not just limited to that, that can help one experience the truth of this mathematical reality, not just the intellectual idea of it, brings resilience. can cultivate a sense of the ability to adapt even when things don't work out the way you want. I told you before we started speaking that I had 3 little strokes, largely asymptomatic, 3 weeks ago. So I had little mass extinction events in my brain. Mass extinction events happen. You can see I'm not particularly upset. I'm doing fine. It's going to require reordering a lot of how I order my life. I'm more grateful for that than I am afraid of it. And I think it's because I have these concepts in my mind and I have a practice that helped me experience the truth of them moment by moment.
My very special guest today has been Neil Theise. The book is Notes on Complexity, a Scientific Theory of Connection, Consciousness, and Being. It's an extraordinary book. I'm going to read my own endorsement. That will change the way you understand yourself and the universe. It will empower you. We should all be indebted to Neil Theise for this monumental contribution to the science behind all reality. Congratulations, Neil.
Thank you so much, Deepak. Thanks for talking.